Hello, in this lecture we find out the area of the green shape using two different methods. In the drawing we have a quarter circle, A or B is a quarter circle. Inside this quarter circle we have the green quadrilateral AODC, and our mission is to find out the area of this green quadrilateral. In addition, we know that side AC of the quadrilateral is equal to 24 units in its length, and side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green quadrilateral AODC. So first of all, because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees. And also, point O is the center of the circle that we can create by completing this quarter circle to a circle. So from point O, that is the center of the circle, we'll draw perpendicular on chord AC. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC is P. So here we have rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of the circle. From point O, we draw perpendicular OM on chord AB. That is to say, this angle equals 90 degrees and this angle also equals to 90 degrees according to our construction. According to this rule number 11, the perpendicular OM also bisects chord AB. That is to say, AM equals to MB. Okay. Whenever you draw a perpendicular from the center of the circle to a chord, that perpendicular also will bisect the chord. In this case, the perpendicular OM bisects chord AB, that is to say, AM equals to MB. We can implement rule number 11 in our drawing, because in our drawing we have from the center of the circle, that is to say from point O, we draw perpendicular OP in chord AB. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. Therefore, according to rule number 11, the perpendicular OP also bisects chord AC. That is to say, AP equals to PC. AP equals to PC, but in total AC equals to 24, therefore each half must be equal to 24 over 2. That is to say, AP will be equal to 24 over 2, that is 12, and PC must be also equal to 12 units according to rule number 11. So AP equals to 12 units, and PC also equals to 12 units. Okay. The next step from point D, we will draw perpendicular on PO. So this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to our construction. We define the touching point of the perpendicular from point D and PO is Q. We created the quadrilateral PCDQ. In this quadrilateral PCDQ, we have 1, 2, 3 right angles. The sum of 3 right angles is 90 times 3 is 270 degrees, plus the size of this fourth angle. In total, they must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle must be equal to 90 degrees. Again, in order to complete the sum of the angles in this quadrilateral PCDQ to 360 degrees, the missing angle must be equal to 90 degrees. So inside quadrilateral QPPCQ, we have 4 right angles. Therefore, we will relate to quadrilateral PCDQ as a rectangle, And you also know that the opposite sides of rectangle are equal to each other. That is to say, in rectangle PCDQ, PC equals to PQ, but PC is 7, therefore PQ must be also equal to 7 units in its length. In the same rectangle PCDQ, side PC must be equal to the opposite side QD, but PC is 12, therefore QD must be also equal to 12 units in its length. In the next step, we will define the length of this line segment QO as X. And we will focus on the right triangle OQD. This right triangle OQD, we define angle ODQ as alpha. So in the right triangle DQO, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. So the missing angle here equals to 90 degrees minus alpha. We'll define 90 degrees minus alpha is beta. Therefore, the missing angle here must be equal to beta. What is the size of the missing angle here, angle AOP? The size of this angle, angle AOP, must be equal to the big angle, angle AOB, that is equal to 90 degrees minus beta. Again, 90 degrees minus beta must be equal to the missing angle here, angle AOP. I'm writing down the missing angle, angle AOP. This angle must be equal to 90 degrees minus beta. So it is 90 degrees minus beta, but beta is 90 degrees minus alpha, so we substitute beta here by 90 degrees minus alpha. We'll open the brackets here, and we get that 90 degrees minus 90 degrees is 0, and minus times minus is plus. So in total, this expression equals to alpha. In conclusion, found out that the missing angle here, angle AOP, equals to alpha. This angle equals to alpha. The next step, we'll focus on the right triangle APO. On the right triangle APO, this angle equals to 90 degrees, and this angle equals to alpha, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha is equal to beta, so you can write here that this angle equals to beta. In the next step, I'll copy the right triangle OQD in a new page, and you will find out the value of tangent alpha in this right triangle. Side OQ equals to X according to our definition. And side QD equals to 12 units. Angle OQD equals to alpha. So here, this is the right green triangle OQD that I copied from the original drawing. This right triangle OQD, tangents alpha equals to X over 12. Here, repeat again, this right triangle OQD, tangents alpha equals to X over 12. In the next step, I will copy the right triangle APO here in the new page and we find out the value of tangent alpha in this right angle triangle. Side AP equals to 12 units in its length. And what is the length of side PO? From the drawing it is very easy to see that PO in total equals to 7 plus 6. And angle AOP equals to alpha. AOP. So this is the right triangle APO that I copied from the original drawing. In this right triangle APO we get that tangent alpha equals to 12 over x plus 7. And again, in this right triangle APO, tangent alpha equals to 12 plus x plus 7. So we have two different expressions for tangent alpha. In the next step, we'll create equation number 3. According to equation number 3, equation number 3 states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. So tangent alpha according to equation number 1 equals to x over 12. And it must be equal to tangent alpha according to equation number 2, that is equals to 12 over x plus 7. So here we cross multiply this equation, equation number 3, and we get that according to equation number 3, x times x plus 7 equals to 12 times 12, that is 144. We'll open the brackets on this side of the equation number 3 and we get that x times x is x squared plus 7x, that is equal to 144. We subtract 144 from this equation and we get that x squared plus 7x minus 144 is equal to 0. So this is a quadratic equation, and then the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. This general formula, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for, and we find out the value of x according to the following formula. X equals to minus b plus minus the square root of b squared minus 4 times a times c over 2a. In our specific quadratic equation, x squared plus 7x minus 144 equals to 0, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. Now we put the data inside the equation for x in order to find out the value of the values of x. I will remind you that x, according to our definition, x equals to the length of line segment QO. So according to this equation, we get that x equals to minus b. B is 7, so minus b is minus 7 plus minus square root of b squared. B is 7, so b squared is 7 squared, that is 49. Minus 4 times a is 1, times c, that is minus 144. Over 2a. This is over 2 times 1, that is 2. So x equals to minus 7 plus minus 4 times minus 144 is plus 576, and plus 576 plus 49 is equals to 625. So inside the root we left only with 625 over 2. Okay, so found out actually that x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here you have two solutions that are possible for x. The first solution for x that is x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So according to the first solution for x, we found out that x equals to minus 16. But because of the fact that x is a length, and the length must be a positive number, we cancel the solution for x that is a negative number, and we left only with the second solution that is possible for x. X equals to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is 9. So finally we found out that x equals to 9 units in its length. That is to say, this line segment x, QO, that is equal to x, is equal to 9 units. So in the next step, we divide the area. Our mission is to find out the area of the green shape. We divide this area into 3 parts. The first part will be the area of the right green triangle APO that will define SA1. The second part will be the area of the green right triangle OQD that will define SA2. And finally the third part of the green shape will be the area of rectangle PCDQ that will define SA3. It's very clear from the drawing that the total area of the green shape equals to A1 plus A2 plus A3. So I write it down. The area of the green shape in total must be equal to A1 plus A2 plus A3. The next step we will calculate each area separately, and then we will add the areas together. This will be, of course, the area of the green shape. So we start with A1. A1 is the area of the green right triangle APO, so I will copy the green right triangle APO in the new page, and we find out the area of this green right triangle. side AP of this right triangle APO equals to 12 units in length. Side PO equals to 7 plus x. But x is 9, so it is 7 plus 9, that is 16. PO equals to 16 units in its length. In total, so actually, this is the right triangle APO that I copied from the original drawing. This is the value of A1. So the area of this green right triangle APO must be equal to AP times PO over 2. AP is 12, PO is 16, divided by 2. 16 over 2 is 8, so in total this expression equals to 8 times 12, that is actually 96. So actually found out that A1 equals to 96 square units in its area. This is actually the area of the right triangle APO. In the next step we find out the value of A2. A2 is the area of the right triangle OQD, so I copy right triangle OQD in the new page, and we find out the area of this right triangle. OQ equals to x, and x is 9. QD equals to 12 units. Repeat again that the value of A2 is the area of the right triangle OQD that I copied here from the original drawing. The area of this right triangle OQD must be equal to OQ times QD over 2. OQ is 9 times QD, that is 12 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is 54 square units. So A2 in total equals to 54 square units. That is actually the area of this right triangle OQD. And finally, we find out the value of A3. A3 is the area of rectangle PCDQ. The area of any rectangle equals to the length of the rectangle times the width. Repeat again, the area of any rectangle equals to the length of the rectangle times the width. The length is PC and the width is PQ. PC equals to 12 units in its length and PQ equals to 7 units in its length. Therefore, the total area of the rectangle is 12 times 7, that is 84. So in conclusion, found out that A3 equals to 84 square units. And the total area of the green shape equals to A1 plus A2 plus A3, so I already mentioned before. A1 equals to 96, A2 equals to 54, and A3 equals to 84. 96 plus 54 it is 150, 150 plus 84 is 234 square units. So in conclusion, we found out that the total area of the green shape is equals to 234 square units. And that is the answer to our question. The total area of this green shape it is equals to 234 square units. In the next step, I will present to you how to find out the area of this green shape according to the second method. Because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees. And point O is the center of the circle that we can create by completing the quarter circle to a circle. So, first of all, we'll join points A and D together by a straight line. By joining points A and D, we created the right triangle ACD. So I'll copy the right triangle ACD in the new page and we'll find out the length of the hypotenuse AD. This is the right triangle ACD. They call it from the original drawing. Here by PT is a progression from Pythagoras theorem. According to the Pythagoras theorem, in this right triangle ACD, AD square equals to AC square plus CD square. Okay, so AD square equals to AC square. AC is 24, therefore AC square is 24 squared, that is 576, plus CD square. CD is 7, therefore CD square is 7 squared, that is 49. So in total AD square equals to 576 plus 49 is 625. We take a root out of this equation and finally found out that AD equals to the square root of 625, that is actually 25. So the length of the hypotenuse AD here is equals to 25 units. In the next step, we'll complete the quarter circle to a circle. Point O is the center of the circle, point A is the point of the circle itself, therefore OA is the radius of the circle that we will define as R. In the next step we will extend the radius AO by a straight line until it touches the circle. We will define the touching point of the extended radius AO and the circle is point M. Point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle that is equals to R according to our definition. We extended the radius AO by straight line, the result AM must be also a straight line. Therefore AM is a chord that passes from point O, that is the center of the circle. Any chord that passes through the center of the circle must be the diameter of the circle. Therefore AM is the diameter of the circle. What is the length of AM? AM is R plus R, that is to R. In conclusion, we found out that AM is the diameter of this circle, that is equal to 2R. In the next step, we'll extend side CD until it touches the circle. The question is where the extended side CD will touch the circle. We'll assume that the extended side CD will not touch the circle at point M, but in another point. For example, we'll assume that the extended side CD will touch the circle at this point, point N. It is given as the question that ACD equals to 90 degrees. When we extend side CD, the angle ACD will not change its size. It will still be equal to 90 degrees. We just extended one leg of the angle by straight line. The result, therefore, the angle itself will not change its size. It will still be equal to 90 degrees. Therefore, peripheral angle ACN that is equal to 90 degrees according to what is given as the question. It rests on chord AN that is not the diameter of the circle. And it contradicts rule number 5. Why? Because according to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here peripheral angle MAN equals to 90 degrees and it rests on AM or on N or on MN, that is the diameter of this circle. And therefore this peripheral angle ACN that is also equals to 90 degrees must rest on AM and not on AN. That is not the diameter of the circle, because it is equal to 90 degrees, it must rest on AM. That is the diameter of the circle. So due to this contradiction, we conclude that the extended side CD will not touch the circle at point N, but at point M. In this way, we will avoid the contradiction. Why? Because if the extended side CD will touch the circle at point M, then we have peripheral angle ACM that is equal to 90 degrees, and this peripheral angle rests on AM, that is the diameter of the circle, exactly according to rule number 5. Therefore, CDM is one straight line. In the next step, we focus on this side of the straight line AM at point O. And this side of AM at point O, the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles from one side of a straight line equals to 180 degrees. So which angles we have at this side of AM at point O? We have this angle plus the missing angle. In total, they must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. In the next step, we prove that the green right triangle AOD is congruent to the white right triangle MOD. So write it down again, right triangle AOD is congruent to the right triangle MOD. So why those two right triangles congruent to each other? First of all, AO equals to OM. AO equals to OM. Repeat again. Side AO of the green triangle equals to side OM of the white triangle. They are both the radii of the circle, therefore they are equal to each other. In addition, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So angle AOD of the green triangle equals to this angle, angle MOD in the right triangle. Angle AOD in the green triangle equals to angle MOD in the white triangle. They are both equal to 90 degrees, therefore they are equal to each other. And finally, side OD is a common side that belongs to both triangles. So you can write down that OD equals to itself. It's a common side that belongs to both triangles. But again, side OD equals to itself as a common side that belongs to both triangles. So actually prove that the green right triangle AOD is congruent this is the sign of congruent to the right triangle MOD according to side angle side all. I'll explain what I mean. Those two sides and the angle between the two sides in the green triangle are correspondingly congruent to those two sides and the angle between those two sides in the right triangle. Therefore, those two right triangles congruent to each other according to side angle side rule. And from the fact that the two right triangles congruent to each other, we will derive that AD in the green triangle, side AD in the green triangle is equal to side DM in the white triangle. Repeat again. Side AD in the green triangle equals to side DM in the white triangle. But AD equals to 25 units, so we can write here that AD equals to 25 units. And from this equation, 25 equals to AD equals to DM, we will derive that DM is also equals to 25 units in its length. DM also equals to 25 units in its length. So what is the total length of side CM? CM equals to CD plus DM because CDM is one straight line. That is to say CM equals to CD that is 7 plus DM that is 25. 7 plus 25 is 32. So in total CM equals to 32 units in its length. AC equals to 24 units. And AM it is the diameter of the circle that is equal to 2R. So copy the right triangle ACM in a new page and we will implement in this right triangle ACM the Pythagoras theorem. So actually this is the right triangle ACM that I copied from the original drawing. AC equals to 24 units, CM equals to 42 units, and the hypotenuse AM equals to 2R, it is the diameter of the circle. According to the Pythagoras theorem, here by PT is the evaluation for Pythagoras theorem. We get that AM square equals to AC square plus CM square. So AM is 2R, therefore AM square is 2R squared, that is 4R squared. Is equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576 plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So 4R squared equals to 576 plus 1024. Total it is equals to 1600. So 4R squared equals to 1600. We'll divide this equation by 4 and finally we get that R squared equals to 1600 over 4 is 400. R squared equals to 400. We'll take a root out of this equation. And finally we get that R equals to the square root of 400, that is 20. So the radius of this circle R is equals to 20 units. In the next step I will copy the right range triangle AOD in a new page and we'll implement here the Pythagoras theorem in order to find out the missing side OD. Okay. So actually, this is the right range triangle AOD that I copied from the original drawing. By PT evaluation for Pythagoras theorem. This right triangle AOD according to the Pythagoras theorem, we get that AD square equals to AO square plus OD square. AD is 25, therefore AD square is 25 squared, that is 625. And it is equal to AO square. AO is 20, therefore AO square is 20 squared, that is 400. Plus OD square. OD is the missing side, so we leave it as it is. We subtract 400 from this equation and we get that 625 minus 400 is 225. And this equals to OD square. We take a root out of this equation and finally we get that OD equals to the square root of 225, that is 15. So this missing side OD equals to 15 units in its length. What is the area? We are looking for the area of the green shape. We divide the area of this green shape into two parts. The first part will be the area of the right green triangle AOD that we will define as A1. And the second part will be the area of the green right triangle ACD that we will define as A2. It is very clear from the drawing that the total area of those two, of this green shape, it is equals to A1 plus A2, that is the sum of the areas of the two right triangles, triangle AOD and triangle ACD. So write it down. The area of the green shape in total must be equal to A1 plus A2. So we find out the area of each part, and then we'll add the two parts together. That will be, of course, the area of the green shape. A1 is the area of the green right triangle AOD, so I copy the green right triangle here, and we'll find out the area of this right triangle. Repeat again, the area, and copy the right triangle AOD here, and this is the value of A1, the area of this right triangle. The area of this right triangle equals to OD times AO over 2. OD is 15, AO is 20 over 2. 15 times 20 is 300, and 300 over 2 it is 150. So if we found out that A1, that is the area of the right triangle AOD, equals to 150 square units. In the next step, we'll find out the value of A2, that is the area of the green right triangle ADO. So I'll copy the green right triangle in a new page, and we'll find out the area of this green right triangle, triangle ACD. So actually, this is the green right triangle ACD that I copied from the original drawing. The area of this green right triangle is the value of A2. The area of triangle ACD equals to AC times CD over 2. AC is 24 times CD is 7 over 2. 24 over 2 is 12, so in total this expression equals to 12 times 7, that is actually 84. We actually found out that A2 equals to 84 square units, and we have already found out that A1 equals to 150 square units. The total area of the green shape is equal to A1 plus A2. A1 is 84 plus A2 is 150. 84 plus 150 is 234. So I found out that the area of the green shape in total it is equal to 234 square units. Okay, that is the answer to our question. The area of this green shape equals to 234 square units. In the next step, I'll summarize the lecture. We'll start with the first method, of course. In this lecture, we found out the area of this green shape. This is actually the area of quadrilateral AODC. In the drawing, we have a quarter circle. AOB is a quarter circle. Inside this quarter circle, we have to find out the area of the green quadrilateral AODC. In addition, we know that side AC of the quadrilateral equals to 24 units in its length, side CD equals to 7 units in its length, and this angle ACD equals to 90 degrees. Again, our mission is to find out the area of the green quadrilateral AODC. Okay, because of the fact that AOB is a quarter circle, it means that this angle AOB equal to 90 degrees, and point O is the center of the circle that we can create by completing this quarter circle to a circle. So from point O, that is the center of the circle, we go perpendicular on chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point O and AC as P. Then we have here rule number 11. According to rule number 11, the perpendicular to a chord drawn from the center of the circle bisects the chord. Point O is the center of the circle. From point O, we draw perpendicular OM. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. According to this rule number 11, the perpendicular OM to chord AB also bisects chord AB. That is to say, AM equals to MB. We can actually implement rule number 11 in our drawing. Why? Because in our drawing, we have point O is the center of the circle. From point O, we draw perpendicular OP on chord AC. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. According to rule number 11, the perpendicular OP on chord AC also bisects chord AC. That is to say, AP equals to PC. In total, AC equals to 24. Therefore, each half will be equal to 24 over 2. That is to say, AP equals to 24 over 2, that is 12, and the second half PC must be also equal to 12 units in its length. And so the reason that AP equals to PC equals to 12 is due to the implementation of rule number 11 in our drawing. Okay. Then, from point D, we draw perpendicular on PO. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. We define the touching point of the perpendicular from point D in PO as O. In this way, we created quadrilateral PCDQ. In this quadrilateral PCDQ, we have 1, 2, 3 right angles. This angle equals to 90 degrees according to what is given as the question. The sum of 3 right angles is 90 times 3 is 270 degrees plus the missing angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees. So, inside quadrilateral QPCD, we have 4 right angles. Therefore, when you relate to quadrilateral PCDQ, it's a rectangle. And you know that the opposite sides of a rectangle are equal to each other. That is to say, PQ equals to CD, but CD is 7, therefore PQ must be also equal to 7 units in its length. In the same rectangle PCDQ, PC must be also equal to QD. But PC is 12, therefore QD must be also equal to 12 units in its length. In the next step, we define the length of this 97QO as X. Then we focus on the right green triangle OQD. This right triangle OQD. We define the angle ODQ, this angle as alpha. So this angle equals to alpha according to our definition. This angle equals to 90 degrees. Therefore, the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. This is the sum of the angles in any triangle. So this angle equals to 90 degrees minus alpha, but we define 90 degrees minus alpha as beta, therefore this angle will be equal to beta. Angle AOB equals to 90 degrees because AOB is a quarter circle. This angle equals to beta, therefore the missing angle here must be equal to 90 degrees minus beta. So the missing angle, angle AOP, must be equal to 90 degrees minus beta. But according to our definition, beta equals to 90 degrees minus alpha. Therefore we can substitute beta here by 90 degrees minus alpha. Then we open the brackets here. 90 degrees minus 90 degrees is 0. And minus times minus is plus, so in total this expression equals to alpha. That is to say, the missing angle here, angle AOP, equals to alpha. Then we focus on the right angle APO. In the right angle APO, this angle equals to alpha. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But according to our definition, 90 degrees minus alpha equals to beta. Therefore this angle equals to beta. Then I copied the right triangle OQD in a new page, and we found out the value of triangle alpha in this green right triangle OQD. This is the right triangle OQD that I copied from the original drawing. OQ equals to x according to our definition, and QD equals to 12 units. Angle ODQ equals to alpha. In this right triangle OQD, we'll get that tangent alpha equals to x over 12. Again, in this right triangle OQD, tangent alpha equals to x over 12. This is equation number 1. Then I copied the right triangle APO, the right green triangle APO, in a new page, and we found out the value of tangent alpha in this right green triangle. This is the right triangle APO that I copied from the original domain. Side AP equals to 12 units in its length. What is the length of PO? Side PO, from the drawing it is very easy to see that PO equals to 7 plus x or x plus 7. PO equals to x plus 7. Okay, PO equals to x plus 7 or 7 plus x, it is the same. And angle POA equals to alpha. In this right triangle APO, tangent alpha equals to 12 over x plus 7. And again, tangent alpha in this right triangle APO equals to 12 over x plus 7. So we have two different expressions for tangent alpha. Then we created equation number 3 that states that tangent alpha according to equation number 1 must be equal to tangent alpha according to equation number 2. Tangent alpha according to equation number 1 is x over 12. And this must be equal to tangent alpha according to equation number 2, that is 12 over x plus 7. Then we cross multiply this equation and finally found out that x times x plus 7 equals to 12 times 12, that is 144. Then we subtracted 144 from this equation and found out that x squared plus 7x minus 144 equals to 0. So here this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. Here, a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula: x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, x squared plus 7x minus 144 equals to 0, the coefficient a equals to 1, the coefficient b equals to 7, and the coefficient c equals to minus 144. So we put the data inside the formula for x in order to find out the value or the values of x. I will remind you that according to our definition, x is the length of line segment OQ. Okay. So according to this equation, we get that x equals to minus b. b is 7, so minus b is minus 7, plus minus the square root of b squared. b is 7, so b squared is 7 squared, that is 49, minus 4 times a is 1, times c, that is minus 144 over 2a. a is 1, so 2 times 1 is 2. So inside the root we have minus 4 times 144 is plus 576. Plus 576 plus 49, in total is equal to 625. So inside the root we left only with 625. So x equals to minus 7 plus minus the square root of 625 over 2. So x equals to minus 7 plus minus the square root of 625 is 25 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to minus 7 minus 25 over 2. Minus 7 minus 25 is minus 32, and minus 32 over 2 is minus 16. So in conclusion, we found out that according to the first solution for x equals to 116, but because of the fact that x is the length, and the length must be a positive number, we cancel this solution for x, that is a negative number, so we're left only with the second solution that is possible for x. X could be also equal to minus 7 plus 25 over 2. 25 minus 7 is 18, and 18 over 2 is x. 18 over 2 is 9, so here x, the length of 9 segment QO is x, that is equal to 9. Then we divided, our mission is to find out the area of this green shape. We divided this green shape into three parts. The first part is the area of the green right triangle APO that we define as A1. The second part of the green shape is the area of the green triangle OQD that we defined as A2. And finally, the third part of the green shape is the area of rectangle PCDQ that we defined as A3. It is very clear from the drawing that the total area of the green shape equals to A1 plus A2 plus A3. Repeat again, the total area of the green shape equals to A1 plus A2 plus A3. We calculated each area separately, and then we added the three areas together. It must be also, of course, equal to the area of the green shape. A1 is the area of the green right triangle APO, so I copy the right green triangle APO here, and find out the area of this right triangle. Side AP equals to 12 units in itself. PO equals to x plus 7, and x is 9, so total PO equals to 9 plus 7, that is 16. So A1 equals to AP times PO over 2. AP is 12, PO is 16 over 2. So 16 over 2 is 8, so in total this expression equals to 8 times 12 over 8 times 12. 8 times 12 is 96. So I found out that the area of this right triangle APO is 96, therefore A1 equals to 96 square units. Then we found out the value of A2. A2 is the area of the right triangle QOD. Side QO equals to x, that is 9, and QD equals to 12 units. So A2 equals to the area of the right triangle QOD. The area of the right triangle QOD equals to QD times QO over 2. QD is 12, QO is 9, so it is 12 times 9 over 2. 12 over 2 is 6, so in total this expression equals to 6 times 9, that is 54. So in conclusion, we found out that the value of A2 is the area of the right triangle QOD, that is 54 square units, and finally we found out the value of A3, that is the area of rectangle PCDQ. The area of any rectangle is the length of the rectangle times the width. The length is PO and the width is PQ. PO equals to 12 and PQ equals to 7, so the area of the rectangle PCDQ equals to 12 times 7, that is 84. So the area of rectangle PCDQ equals to 84 square units. And the total area of the green shape equals to A1 plus A2 plus A3. Again, the total area of the green shape equals to A1 plus A2 plus A3. A1 is 96, A2 is 54, and A3 is 83. 96 plus 54, it is 150, 150 plus 84, it is 234 square units. So in conclusion, we found out that the area of this green shape equals to 234 square units. We finished with the first method. In the next step, I presented to you how to find out the area of this green shape according to the second method. In the second method, we joined points A and D together by straight line. In this way, we created the right green triangle ACD. So I copied the right green triangle ACD in a new page and found out the length of the hypotenuse AD. This is the right green triangle ACD that I copied from the original drawing. AC equals to 24 units, CD equals to 7 units. Here by PT evaluation from Pythagoras theorem, according to the Pythagoras theorem, in this right triangle ACD, AD squared equals to AC squared plus CD squared. So AD squared equals to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CD squared. CD is 7, therefore CD squared is 7 squared, that is 49. So AD squared in total equals to 576 plus 49, that is 625. We took a root out of this equation and finally found out that AD equals to the square root of 625, that is 25. So actually found out that the length of the hypotenuse AD in the right triangle ACD equals to 25 units. In the next step, again, because of the fact that AOB is a quarter circle, it means that this angle AOB equals to 90 degrees, and point O is the center of the circle that we can create by completing this quarter circle to a circle. So in the next step, we completed this quarter circle to a circle. So here point O is the center of the circle. Point A is the point of the circle itself, therefore OA is the radius of this circle that we defined this R. Then we extended the radius AO by a straight line until it touches the circle at point M. We define the touching point of the extended radius AO in the circle as M. So point O is the center of the circle, point M is the point of the circle itself, therefore OM is the radius of the circle that is equal to R according to our definition. So we have here chord AM that touches the circle at point A and M. So AM is a chord that passes for point O, that is the center of the circle. Any chord that passes for the center of the circle must be the diameter of the circle. Therefore AM is the diameter of the circle. And what is the length of chord AM? AM equals to R plus R, that is to R. So in conclusion, we can say that AM is the diameter of the circle, and the length of the diameter is 2R. Okay? Then, so here we have with extended side CD by a straight line until it touches the circle. The question is where the extended side D will touch the circle. We will assume that the extended side CD will touch the circle not at point M but at point N. And then we will have peripheral angle ACN that is equal to 90 degrees according to what is given as the equation, because when we extended side CD by a straight line, the angle itself here still will remain the same angle. It still will be 90 degrees. Therefore, we will have peripheral angle ACN that is equal to 90 degrees, and this peripheral angle ACN rests on AN. AN is not the diameter of the circle, it contradicts rule number 5. Why? Because peripheral angle ACN that is equal to 90 degrees must rest on AM, that is the diameter of the circle. According to rule number 5, any peripheral angle that is equal to 90 degrees must rest on the diameter of the circle. Here, peripheral angle MAN equals to 90 degrees, and therefore it rests on MN, that is the diameter of the circle. And according to rule number 5, this peripheral angle ACN that is equal to 90 degrees must rest on AM. But actually it doesn't rest on AM, that is the diameter of the circle, but it rests on chord AN, that is not the diameter of the circle. It contradicts rule number 5. So due to this contradiction, we will conclude that the extended side CD will not touch the circle at point N, but at point M. And then we will not have any more contradiction to rule number 5, because here we will have peripheral angle ACM that is equal to 90 degrees, and this peripheral angle that is equal to 90 degrees indeed rests on AM, that is the diameter of the circle, exactly according to rule number 5. Okay, so we can conclude from this discussion that the extended side CD will touch the circle at point M and not in any other point. In this way, we will avoid the contradiction to rule number 5. Okay, and therefore CDM is one straight line. Because we extended the straight line CD by straight line, the result is CM. That must be also one straight line. So if we focus on this side of the straight line AM at point O, the sum of the angles must be equal to 180 degrees. According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have with this side of AM at point O? We have this angle that is equal to 90 degrees plus the missing angle in total must be equal to 180 degrees according to the rule that I mentioned. Therefore, this missing angle must be equal to 90 degrees. Then we put that the green right triangle AOD is congruent to the white right triangle ODM. Why those two right triangles can go into each other? First of all, AO equals to OM. Here, side AO of the green triangle equals to side OM of the white triangle. They are both the radii of the circle, therefore they are equal to each other. In addition, those two angles they are both equal to 90 degrees, therefore they are equal to each other. Angle AOD of the green triangle equals to angle MOD of the white triangle. They are both equal to 90 degrees, therefore they are equal to each other. And finally, side DO is a common side that belongs to both triangles, so side DO equals to itself is a common side that belongs to both triangles. OD equals to OD is a common side that belongs to both triangles, so we actually succeeded to prove that those two triangles can go into each other according to side and side rule. I'll explain what I mean. Those two sides and the angle between them in the green triangle are correspondingly can go into those two sides and the angle between them in the white triangle. Therefore, those two triangles can go into each other according to side angle side rule. Again, the green triangle AOD can go into the white triangle MOD according to side angle side rule. And from the fact that those two right triangles can go into each other, we will derive that side AD in the green triangle is equal to side DM in the white triangle. Okay, again, side AD in the green triangle equals to side DM in the white triangle. According to the rule that corresponding sides in congruent triangles are equal to each other. That is to say, those two triangles can go into each other, therefore the two corresponding sides, that is to say AD and DM, must be also equal to each other. But AD equals to 25. So we can write here that AD equals to 25, and from this equation 25 equals to AD equals to DM, we will derive that DM also equals to 25 units in its length. If this side DM equals to 25 units in its length. So in total, the length of side MC equals to MD plus DC because MDC is one straight line. So MC equals to MD, that is 25, plus DC, that is 7. In total, MC equals to 25 plus 7, that is 32. So CM equals to 32 units, AC equals to 24 units, and AM is the diameter of the circle, that's equal to 2R. So we copy the right triangle ACM in a new page here, and we implemented this right triangle ACM, the Pythagoras theorem. I repeat again that AC equals to 24 units according to what is given as the question. CM equals to 32 units according to what we just right now calculated. And AM is the diameter of the circle, that is equal to 2R. According to the Pythagoras theorem, in this right triangle, ACM, AM squared equals to AC squared plus CM squared. AM is 2R, so AM squared is 2R squared, that is 4R squared, that is equal to AC squared. AC is 24, therefore AC squared is 24 squared, that is 576, plus CM squared. CM is 32, therefore CM squared is 32 squared, that is 1024. So 4R squared equals to in total to 576 plus 1024, that is equals to 1600. So 4R squared equals to 1600, we divided this equation by 4 and found out that R squared equals to 1600 over 4, that is 400. So R squared equals to 400. We took out from this equation and finally found out that R equals to the square root of 400, that is 20. So the radius of this circle R equals to 20 units in its length. Then I copied the right green triangle AOD in a new page and we found out the missing side here, OD, this is the missing side, by implementing the Pythagoras theorem on this green right triangle AOD. This is the green right triangle AOD that I copied from the original domain. AO equals to 20, AD equals to 25. OD is the only missing side here. This right triangle AOD according to the Pythagoras theorem, we get that AD squared equals to AO squared plus OD squared. AD is 25, therefore OD squared is 25 squared, that is 625. and it is equal to AO square. AO is 20, therefore AO square is 20 squared, that is 400 plus OD square. OD is the missing sign, so we limit it is. Here we subtract 400 from this equation and found out that 625 minus 400 is 225, that is equal to OD square. We took out of this equation and finally found out that OD equals to the square root of 225, that is 15. So the missing sign here in the right triangle AOD equals to 15 units in its length. So our mission is to find out the area of this green shape. The area of this green shape equals to the area of the right green triangle AOD that we defined as A1 plus the area of the green right triangle ACD that we defined as A2. It is very clear from the drawing that the total area of the green shape equals to A1 plus A2. Repeat again, the area of the green shape in total equals to A1 plus A2. A1 is the area of the right green triangle AOD, and copy the right green triangle AOD here, and find out the value of this right triangle, that is actually 1. AU equals to 20 units in its length, OD equals to 15, therefore the area of the right triangle AOD equals to AO times OD over 2. AO is 20, OD is 15, divided by 2. 15 times 20 is 300, and 300 over 2 is 150. So I found out that the area of this right triangle AOD equals to 150 square units. This is the value of A1 plus A2. A2 is the area of the green right triangle AOD. Copy the right green triangle AOD here, and we found out the area of this green right triangle. On top it the area of the A2 is the area of the green right triangle ACD. We already found out that A1 equals to 150 square units. Now we have to find out the value of A2. A2 is the area of the green right triangle ACD. So I copied the green right triangle ACD here. AC equals to 24 and CD equals to 7 units according to what is given us the question. The area of this green right triangle ACD equals to AC times CD over 2. AC is 24, CD is 7 divided by 2. 24 over 2 is 12, so in total this expression equals to 12 times 7. 12 times 7 is 84. So in conclusion, found out that A2 equals to 84 square units, and we already found out that A1 equals to 150 square units. The total area of the green shape equals to A1 plus A2. A1 is 84 and A2 is 150, so A1 plus A2 equals to in total 84 plus 150, that is 234 square units. Repeat again, we found out that the area of this green shape according to the second method is also equals to 234 square units. Okay, thank you very much.